In honor of opening day, it looks like we have a very interesting baseball science question. Why does a knuckleball seem to dance towards home plate?
Definitely. So I'm not the most sporty of people in the world. I like sports.
Are you sure?
Ish.
I saw you climbing that rock.
Oh, those kind of sports I'm totally into.
We didn't see him throwing a rock.
Organized
Yeah.
ball
Team.
team, jersey sports that I just tend to not be. I mean, I love that other people love them. It makes me happy that they make other people happy. So I guess what I'm just trying to say is I'm not super deep into an understanding of knuckleballs and their strategic use in baseball, but I have a general understanding and I can at least talk about the physics behind them. So with a lot of different ball sports, right? Players want to put different kinds of effects on the ball to get the ball to do things besides fly in a straight line. So a really common example of this is in soccer, right? A kicker on a penalty kick might want to get around a wall of players blocking the goal, and so if they can put a significant curve or spin to make the ball curve, they can make the ball move around the wall of players blocking the goal. So things like that are done in baseball as well. You've heard of like a curveball. Curveballs are essentially the same as a curveball in soccer. But in any case, what we're looking at is in a knuckleball, you've got a much different type of throw going on. Knuckleballs are slow, and whereas with a lot of different things that are done with balls, you want to put a lot of spin on them. In the case of a knuckleball, you want to put very little spin on the ball. So if we could jump to my screen really quickly. This is a diagram that actually is more used to show how golf balls fly through the air, but it'll serve our purposes. You can just sort of see the difference shown between the airflow on a smooth ball and then the airflow on a golf ball. Side note, the divots in golf balls create a little bit of turbulence that allows, you can see this air pocket here, the wake pocket that's created, to be more narrow on a golf ball, which means that the golf ball has less drag, which means that golf balls can fly further. That's a little bit unrelated to what we're talking about, but just looking at these airflow diagrams, just thinking about the way that there's this kind of laminar flow that goes around a smooth ball, you've got to imagine now with a baseball, we don't have an entirely smooth ball. So let me just show right here. Here's somebody holding a baseball in sort of the knuckleball pitch grip. You can see that they're using their fingers to hold it in sort of a strange way, and they're actually just going to push the ball forward. In an ideal knuckleball pitch, you actually don't want the ball to rotate more than about a half rotation as it moves toward the plate. But again, just looking back at this diagram that shows the smooth airflow, or the airflow over the smooth ball, you can imagine that parts of the baseball are just like this, and so that smooth that slow pitch will fly smoothly through the air until the point when one of these stitches here, where's my thing? Oh. One of these stitches here knocks into the airflow, and then that's going to create a pocket of turbulence. And the ball will do what's called braking in the direction of that pocket of turbulence. But because the stitches are stitched on the baseball in sort of a curved pattern, you can have sort of irregular moments when a stitch will hit or not hit, and so it can be very difficult for a batter to know what to expect with a knuckleball. And I have this GIF that we'll just show here. A knuckleball, and I can probably blow it up a little bit because that's probably small on your screen. This is a pitcher for the Blue Jays. Again, I'm not a big baseball person.
R.A. Dickey.
R.A. Dickey, thank you. So you can just see, and it's hard to see what was referred to in here as the dance, but from the perspective of the pitcher, it appears as though the ball is breaking in an unexpected direction. You can see it sort of rise unexpectedly there and then drop quickly. Knuckleballs, also being slow pitches, tend to drop quickly at the end, which can also throw a batter off.
You can see that the stitches are not moving.
And yeah, that's the other thing is that you can see, and I don't know how well you can pick it up, but you see that it's just that very slow spin, and it's hard to notice, but there's this moment when it kind of happens right there. You get this upward left, from our perspective, a break up and to the left, which is sort of unexpected, and then it pitches downward and to the right. So you'd expect it to, if it's going to go that direction as a curveball, you'd expect it to continue that way. But as a knuckleball, it can pitch right back the other direction as soon as the stitch moves out of the way of the airflow and reduces that turbulence. So yeah, knuckleball, really effective pitch is my understanding because it can throw batters off so much. On the other hand, one of the most difficult to master, they say.
Yes,
Oh, it looks really hard.
there's only 3 pitchers in modern baseball history that were knuckleballers: Tim Wakefield, R.A. Dickey, and then a young kid who pitches for Boston now as well. So
Wow.
yeah,
Well,
R.A.
that's-
Dickey now plays for the Braves.
Oh, he now plays for the Braves, but he was playing for the Blue Jays at this time. Is that right?